All right, so for this last section, we are still determining the area of each given triangle. However, you will notice that these triangles do not lie flat. Like the ones before, they had a horizontal side. Over here, we don't have a horizontal side. So unfortunately, we are going to have to do a little bit more work for these. And I thought about ways that I can make it a little bit easier for you. So I think for one of the sections, we can use Desmos.com. Let me just write that website over here, Desmos.com. So you can use Desmos.com for one part of it, and hopefully that can help you out so that it can shorten the problem a little bit, because I know these problems might take a long time. Okay, so once again, the formula for area is still 1/2 base times height. So we can find our base by looking for whichever side you want to be your base. For me personally, I think base is like a bottom side. So I'm just going to choose this one because it's kind of the closest to being on the floor. It's the closest one to being the base. So we need to figure out the base. And so to figure out the base, we're going to have to use the distance formula. Let me actually write out these 2 points. What are these points? This is 3, 4, and this one is 6, 7, 2. Okay, so our distance formula is x2 minus x1 squared plus y2 minus y1 squared, and then our 2 points are 3, 4, 7, 2, this one being x1 and y1 because it's both part of your first point. X is first, y is second, and then x2, y2 because they are your second point. And let's plug it in. X2 is 7, minus x1 is 3, y2 is 2, minus y1 is 4. And then we simplify again, so 7 minus 3, that gives us 4. 2 minus 4, that gives us negative 2. 4 squared is 16. Negative 2 squared is 4, positive. Remember, negative times negative is a positive. And then we got square root of 20. Let's use a calculator. This gives us 4.472. Remember, we're rounding to the nearest hundredths. So let's take a look at that 2 that is next to our hundredths place. 2 is a small number, so that means we're going to keep the 7 as it is, so 4.47. This is our base. All right. Wow, I kind of ran out of space already, but we're going to need a lot more space to figure out the height. So to figure out the height, you actually want to make sure your height is perpendicular to your base. So let's find out what the slope of our base is. So base is this black line that's on our triangle. And to find the slope, we want to do the rise over run. So this is our base slope. How much do we rise to go from one point to another? If I want to go from N to E, I have to go down 2. So that's negative 2. And then to run, I'm going to go right 4. So that is a positive 4. So it looks like my base slope is negative 2 over 4, which simplifies to negative 1/2. Because you can divide the top by 2 and you can divide the bottom by 2. So then you can simplify this fraction, negative 2 over 4. You can simplify that to negative 1/2. So here is our base slope. So now for the height slope, we want the opposite negative or opposite reciprocal. So since the base slope is negative 1/2, we want it now to be positive. That's what the opposite means. So you switch the sign. If it was negative, you make it positive. If it was positive, you make it negative. So in this case, we had a negative. I'm going to make it a positive now. And then we have reciprocal. Reciprocal just means you flip your fraction. So instead of 1 over 2, I now have 2 over 1. So just to recap, to do a perpendicular slope, which is what we want our base and height to have. You want them to be perpendicular. Then you want the opposite sign. Opposite sign, and then you want reciprocal, which means you want to flip it. So we switched the sign from negative to positive, and then we flipped the fraction from 1/2 to 2/1. So this is the slope that we want to achieve. And so how do we apply this slope? Well, let's take a look at point O, which is the furthest one from our base. And we're going to start from point O, and then you're going to go up 2 and right 1. But that's kind of in the opposite direction of where we want our base to be. So I'm just going to follow that same pattern, but in the opposite direction. So instead of up 2, right 1, I'm going to go down 2, left 1. Notice that it's still along the same line. It's just that it's in the opposite direction so that we can actually go towards our base. So once again, down 2, left 1, down 2, left 1, and then I'm going to connect all of that. And I'm just going to stop there at the actual base. And so now the question becomes, what is this point in blue that I am marking on our graph? What is this point? We need to know this point so that we can find the distance between my blue point and the point O, which is at 8,9. No, 8,8. Sorry. A little bit hard to see. Wait, isn't it 9,8? Is that 8,8? Okay. Just counting where O is, it's at 8,8. Okay, so we know that O is at 8,8, and we need to figure out what the blue dot is. Where is that blue dot? So in order to figure out the blue dot, this is the part where we can use Desmos a little bit to help us out. We are going to write an equation for the line NE. This is the line NE. We're going to write an equation for this line. And then we're going to write an equation for the line, for our height line. We're going to write an equation for this. And then I'm going to use Desmos to find the intersection point so that there's a little bit less work for you to do on paper. Okay, so in order to write the equation of, let's do the yellow line first. Let me find some space. So I'm going to pause the video here and I'm going to find some space for myself. All right, I found space by shrinking my old work. Okay, I'm ready to keep going. So let's go ahead and find the equation for the yellow line. I'm just going to call it NE. Okay, so there's this equation type that or equation formula that we can use, and it looks like this. Y minus y1 is equal to mx minus x1. So this is called point slope form. I don't remember if we've done it that often. I know usually we use the y equals mx plus b, but it is a very similar equation. As you can see, there's a y on one side, and then it's m multiplied by x's. So it is very similar, and I'm going to show you how to use it. So all we have to do to get our equation in point slope form is to know the equation, to know the point that is on the line, and to know the slope of the line. So we've already figured out that the slope of that yellow line, the slope of our base, is -1/2. Remember, we did that when we calculated our base slope, right over here. So I'm going to replace the m with -1/2. Okay, and then so this y, you just write it as a y. The minus y1, we're actually going to figure out which point do we want to use. We can either choose n or e, because both of those points are on our yellow line, and it's up to us. So normally I would ask you guys which point you want to use, because it doesn't matter which one. They'll have the same answer. But I'm just going to choose 3, 4 because it's easier. So I'm going to choose 3, 4. So in the 3, 4 points that we've chosen, this point, the 4 is the y value. So I'm going to say -4. So I changed the y1 to the 4. we already replaced the slope. This x, we just write it down here. And then for minus x1, well, what do you think the x1 value is? It's the x value in our point. So remember, our point is 3, 4. So the x value is 3. So in our equation, I'm going to write minus 3. So the equation for NE becomes literally this. Y minus 4 is equal to negative 1/2 parentheses x minus 3. I'm just going to underline that right here. We will type this into Desmos in just a moment. Let's find the equation of our purple line. Remember, our purple line's the height, so I'm just going to call it the height. Okay, so once again, we're going to use point slope form. And then we're going to have y minus something is equal to the slope, parentheses, x minus something. Okay, so what are those things that we need to fill in? Well, first we can fill in our slope, the m value. Remember our height slope that we found was the opposite reciprocal, so we said it was 2/1. You can just write that as 2 because 2 divided by 1 is just 2. So that is our slope. Actually, I was supposed to write that in black, so let me write that in black. So we replaced the m with 2 because that was the slope of our height. Next, we just got to pick a point that we know on the purple line, and the only point we know on the purple line is the O, this one. Because the blue point that is also on the purple line, well, that one was the one we want to figure out. So we don't know that blue point. The only point we know on our height is O, so it's 8, 8. So the y value in that point is 8, and the x value in that point is 8. So I will just fill that in onto our equations right over here. So now we have an equation for the height. So now that we have 2 equations, I want us to type those equations into Desmos.com. So I've opened up Desmos.com over here. When you get there, you must click the button in the middle that says Graphing Calculator. Click the button in the middle that says Graphing Calculator. That will bring you to here. And then you literally just want to type in those 2 equations. So I'm going to pause my video and type them in because it'll take me a while, but I don't need you to wait for that, so hold on. All right, so as you can see, I've just typed in those 2 equations, literally the 2 equations that we just finished writing out. Those 2 equations are the equations I've typed into Desmos. If you are wondering how to type a fraction, by the way, you use the division button. You use the dividing sign, okay? Top divided by bottom. So for the negative 1/2, I literally did negative 1 divided by 2, and that's how I got a fraction. All right, so now that you've gotten your 2 lines, click on the intersection point. 5.4, 2.8. That is my intersection point. 5.4, 2.8. Going back over here, that means this blue point is 5.4, 2.8. Okay, so now that we know that that blue point is 5.4, 2.8, we can finally calculate the length of our height. So the length of that purple line. So now I need to make more space. I'm going to use the space over here. Length of height. Remember, height is our purple line. So we just need to find the distance between these 2 points. 8, 8 and 5.4, 2.8. Okay, so I'm going to zoom in here to the extreme because I need space. So remember, 8, 8 and 5.4, 2.8, those are the endpoints of our purple height line. So this is our purple height line. 5.4, 2.8 is this blue line, blue dots that we just figured out. And 8, 8 was the original vertex of your triangle. So let's use those 2 points and use a distance formula. Okay, here's our distance formula. This is your x1, y1, x2, oops, y2. There we go. x2 minus x1 y2 minus y1 plug it in and simplify. All right, what is 5.4 minus 8? 2.8 minus 8. And then 2.6, which is negative, and then we're going to square it. Negative 5.2 squared. Add that together. And then square root that. And round to the nearest hundredth. Okay, so this is our h value. Yes, that took a very long time. I'm so sorry. But that was our height value. Let's see. Now, did we already calculate our base? Yes. So now we have our base and we have our height. We can finally plug that in to our area formula, which is 1/2 base times the height. Let me just write it like this. Okay, 1/2 base height. So our base we said was 4.47. Our height we said was 5.81. And so when you multiply this out, let me use a calculator. 4.47 times 5.81. Okay, we get 12.985. Okay, so we want to round to the nearest hundredths. This is our hundredths place. Let's take a look at the number next to it. This is a 5. 5 is a big number. Remember, big numbers are 5, 6, 7, 8, 9. So if it's a big number, we're going to take that 8 and round it up. 12.99. So that 8 became a 9 because we rounded it up. So yes, that was a very lengthy problem. I apologize for how long it can be, but our final answer for the area was 12.99. The concept of calculating the area is still the same. The extra steps simply came from having to calculate the actual intersection point so that we can calculate the height. So I know this was a harder process. There's more steps, but conceptually it is the same thing. So let's take a look at the next one and we'll do it together. So now we have to find the area of triangle DOG, D-O-G. Let's take a look at which one we want to be our base. I think it'd be easy to have this one be our base just because it's the closest to looking horizontal. So this is going to be my base. And so we can start off by finding the length of our base. So what are the 2 points here? This is 4, 2. And this one is 8, 4. Okay, so we can calculate the length of the base in our workspace, which I know is very small, but we can still calculate that. I'm going to write it over here, length of base. Remember the points are 4, 2 and 8, 4. Okay, I'm going to zoom in a ton just because I know I will run out of space later. So we are going to calculate the length of the base using these 2 points because these are the 2 endpoints of our base. All right, so we have our x1, y1 because they're both the first point. Now we have our x2, y2 because those are both our second point. So for x2 minus x1, we have 8 minus 4. y2, 4 minus y1, 2. 8 minus 4 is 4. 4 minus 2 is 2. 16 plus 4. And that gives us the square root of 20, which I know we've done before, but I cannot remember it off the top of my head. So that would be 4.47. Okay, here is the length of our base. I'm going to label that on our graph. Okay, so this is 4.47 as our base. Okay, and then we can calculate our height by first calculating our slope base, our base slope. So the basis slope is rise over run. So to get from one point to the other, how far up do we have to go? How far right do we have to go? So if I'm going from O to G, it looks like I have to go up 2, and then I have to go right 4. So all in all, I have a positive 2 over 4 as my slope. This simplifies to 1/2 because 2 and 4 are both divisible by 2. So if you divide by 2 on the top and bottom, you get 1 over 2. So this is the slope of our base. So to get the slope of our height, remember we want a perpendicular slope, which is the opposite sign and the reciprocal. So we're going to flip it. So our height rise over run is you want the opposite sign. So this was a positive, and I want it to be negative now. And instead of 1 over 2, I'm going to flip it. So 2 over 1. 2 over 1 simplifies to just negative 2. But for the sake of our slope, we're going to just have it as a fraction, negative 2 over 1, which means you want to go down 2 and right 1. So let's go to the farthest point, which is D. I'm going to go down 2, right 1, down 2, right 1, and down 2, right 1. I shall connect those 3 dots. Okay, so that is our height. So now that we've drawn in our height, we need to write an equation for the base, write an equation for the height, so that we can find the intersection point. Oh my gosh, okay. This is your intersection point, and it's really hard to tell what it is. So we're going to have to, once again, find the equation for this base, find the equation for this height, and we're going to type them into Desmos in order to get our intersection point. Okay, so I know that sounds like a lot, but believe me, the book originally wanted you to not type it into Desmos and solve it by hand. I am not going to make you do that. I want you to just type it into Desmos so that you can get that blue point. Okay, what we do have to do though is write the equation for the base OG. Okay, so we're still going to use this y minus y1 is equal to mx minus x1. And then we get to pick a point. Do you want to pick O or do you want to pick G to plug into our equation? Let's pick O. So that would be the 4, 2. So pick this point, the O. Okay, so we're going to write y minus the y1, which is the y value of O. So y minus 2 is equal to m. M is the slope of the base. Remember that the slope of our base, we said over here, was 1/2. X minus x1 is the x value of the point O. So it's 4. And so this is your equation for OG. Now we also need an equation for the height. So for the height, We still need the slope and a point. So we're going to use point slope form. Okay, and then what point can we use? Well, there's only one point that we know on this height line, which is D. So that looks to be 2, 8, 2, 8, yes. Okay, so I'm going to write it out, 2, 8. And then just scrolling so it's easier for me to write. Y minus, the y1 is the y value of our point, so y minus 8 is equal to m. M is the slope. Remember that we said the slope of this line was -2. The height's slope, we said, was -2. All right, parentheses x minus x1 is the x value of the point, so that was a 2. And now we have an equation for the height. Okay, so finally, now with our equation for the base and our equation for the height, we must type these two lines into Desmos, the ones that are being underlined. We're going to type those into Desmos, and then that will help us get the intersection point. So I'm going to go over to Desmos. Let's clear out the old ones. And I'm going to type in the new equations. All right, so as you can see, I have typed in both of those equations. Those are the two equations that we had just figured out, one for the base and one for the height. And then here's our intersection point. So 4.8, 2.4. I'm going to remember that, and let's write it in, 4.8, 2.4. So that is this blue point, 4.8, 2.4. Okay, so now that we know this blue point, we can use this blue point and the original point D to figure out the length of our height. So remember, this is the purple line. The height is what we wanted to find out the length of. So we're going to use the distance formula with those 2 points. And I'm going to do that over this little section. Okay, so remember, for the 2 points that we are using as the endpoints of the height, there are 2, 8, and this one. I'm going to write those down. Okay, so I wrote down those 2 points. I'm going to zoom in here so we actually have space. Write out the distance formula. This is your x1, your y1, your x2, and your y2. Plug it in. x2 minus x1, y2, minus y1, use your calculator. 4.8 minus 2, 2.4 minus 8, 2.4 minus 8. 2.8 times 2.8. Negative 5.6 squared. Add it together. And square root it. All right, so this is the length of your height, 6.26. Okay, so we've got the length of the base. Right over here is the first thing we did. Now we just got the length of the height, the last thing we did. And so finally, we can use it in our area formula, which is 1/2 base height. So 1/2 times the base times the height. And let's type it out into our calculator. And I get 13.9911, which when we round it to the nearest hundredths, take a look at the 1 next to it. 1 is a small number, so we get 13.99. The 9 stays as it is because 1 was a small number. Final answer is 13.99. Okay, so I know this was a lengthy video, but please let me know if you have any questions. Just call me over into your breakout room and I'll help you out. All right, I'll see you in the next video.